All right, just to make up for this session that I've covered in class, but I forgot to record. This is chapter 14, binomial. So I'm just going to write it down. Oh, whoops. Yeah, pen. Chapter 14, last exercise for binomial. And for this question, I suppose it does come up quite frequently in an exam, in the sense that they want you to find n. So if you remember the formula for probability for binomial distribution is, we'd say probability of x equals little x is equal to nx. Your samples are n trials, and how many success you want multiplied to, whoops, go back, whoop, the other way, to the probability of success, and how many times the success you want multiplied to the probability of failure, which is 1 minus the probability of success, to the power of number of times you don't want, number of times you don't want what you're looking for. Okay, and in our cases, we've always been given a number of trials. We've been given to work out the probability, and you know that the probability of success, and so then therefore your job is just to find out the probability of something occurring, and it only changed whether x was greater than or equal to or whatever it was. You played around with binomial CDF and PDF. Okay, now what we're going to do today is to focus on how to get this n value, or n trials. And if you've done the 2 sheets I've given out, binomial distribution test, there was 2 sheets I gave out. Some of the questions you would realize you had to find n. Okay, and I'm going to show you on a calculator this time as well. I didn't really show it in class to analyze it, because you'll find that finding n sometimes is a bit difficult, and I'm going to show you how maybe an alternative to do it as well. Okay, so now we know we're trying to find n, which is the number of trials. So in class I was talking about sometimes we want to find how large a sample size needed to obtain the desired outcome we want. So example I said was, how many times will I have to buy a lottery ticket to ensure I will win? And normally most of the time they would say something like 90% of the time. So how many tickets do I have to buy in order to ensure that I win 90% of the time? Okay, so in that case, if you read the question, if you think about it, it is asking, normally they'll say how many times, and they'll say, you know, how many tickets do you have to buy to win a lottery ticket 90% of the time, something like that. You should know that you'll be finding n based on the way the word the question, and based on the information they've given you as well. So this is an example from your textbook. It says the probability of winning a prize in a game of chance is 0.48. So what they've just told you is, whoops, where's my pen? Okay, they just told you that P, the probability of success, P, is 0.48. And what is success? Success is winning a prize. So think about that. Okay, so success is winning. Okay, that's key. Success is winning. And now the question is, what is the least number of games that must be played to ensure that the probability of winning at least once is more than 95 or 0.95? Okay, so let's highlight a couple of things. When we're reading this, you know, we can get a bit intimidated here. But it says, what is the least number of games? So already that in itself is already hinting out that, well, how many games you have to play dictates the trials. Because each time you play a game, you got 48% chance of winning. So really, it's already asking, what is the minimum number of trials? Meaning, what is n? How much do you need to play minimum to know that you are going to get at least once is more than 0.95. So this is key here. At least once. What does that mean? You're finding the probability of success where you win at least once. So it's greater than or equal to 1. You could win more. You could win more than once. So the goal is to find what is the chances where you find the probability of x greater than or equal to 1 to be more than 0.95. Now, obviously, there's an issue here. Why is there an issue? Because the issue is you don't know how many trials you've got. Because if I knew I was playing 3 games, right? If I knew I was playing 3 games, then it's pretty easy to figure out how to find success. If I was playing 3 games, it's easy to find out probability of x greater than or equal to 1, because you can either have 1 win and then not win, or you can have win and win and not win, and you can also have win, win, win. Okay, so it's easy. You can work out the probability of x equals 1 and probability of x equals 2 and probability of x equals 3 using the binomial distribution formula. Okay, because there's obviously many different ways of rearranging this and many ways to rearrange that, and probably only one way to do that. Okay, but then you add all those together and that tells you the probability of x greater than or equal to 1. That's what you would do. Now, why is this an issue? Because you don't know what n is. You have no idea. It's not 3 games. I just made it up. We don't know what n is. So this is an issue because we don't know what n is. So how many times am I going to add? And that makes it harder. But you see, on the flip side, even though I don't know how many games I'm going to play, but I do know how many games I have played. In my case, probability of x equals 0 is not what I want. And so therefore, what if I just took the because addition of all probabilities have to equal to 1. So what if I just took 1 minus the probability of what I don't want? That should give me the probability of what I want. So what you're meant to do in these type of problems is to rewrite probability of x greater than or equal to 1 with something that is possible to calculate. And this is where it comes into play here. So I know that this is just the same as, this is what I want. I can actually find 1 minus the probability of what I don't want. In my case, I don't want it to be less than 1. And the only thing less than 1 right now is 0. Meaning that you only, so in terms of the example I did before, if you had 3 games, I want to not win at all. Okay? And this one I can actually work out. I can find out the probability of just one thing, which is probability of x equals 0. Now what you can see is, if this is my equation, I can say, well, let's minus 1 on both sides. I can say, all right, minus 1, so 1 minus 1 cancels out, and this will give you negative 0.05. And you've got negative probability of x equals 0, and from here you can then say, let's divide both sides by negative 1, and so negative 1's cancel out and they become positive, but remember the sign changes. So it changes to 0.05, and you got probability of x equals 0. Now, this is where it gets interesting. So from here, this is where you can now try to find probability of x equals 0 using the binomial problem, because you know it's either winning or not winning. So you know it's a binomial problem. So right here, I can then say probability of x equals 0 is the same thing as writing, whoops, I don't know what n is. So I'm going to write n, but I do know my success. I want 0 of them. I want to win nothing. Probability of success is 0.48, and I want to win nothing. Probability of failure would be then 0.52, and obviously I want to win it n times depending on the number of games I have. And I want this to be, whoops, less than 0.05. Okay, so I'm just following on from where I left before. I'm just following on with the idea that this is probability of x equal to 0, just from where I left off. Okay, so now it's all about reducing this and you know, solving it on the CAS calc, or you can do it by hand. But here we go. Thing is, I was trying to explain in 0 that you don't have to use a calculator to solve this. Like, the logic of this is very straightforward. If you have 3 options to choose, let's say A, B, and C, okay? So that's n. Let's say n equals 3. and I said, I want to choose, how many different ways can I not choose any of these? Well, then the only way is just the one way. Now, I know when I'm saying this on the computer, it's hard to understand. What I'm trying to say is, if I said n equals, when I do this, n0, it's very straightforward in the sense that there is only one way to not choose. You just don't choose it. It's sort of like, like you have heads, heads, tails, heads, and tails, okay? If I said I didn't want to get tails at all, there's only one way. If I said I didn't want to get heads at all, then there's only one way. If I don't want to choose out of my 3 options, there is only one way. Don't choose. So that's why n0 logically makes sense that it's 1. But you can prove it using the combinations formula, which I showed you in class. N0 over, this in case is a 0, factorial over n minus 0 factorial. And that's, if we've forgotten, 0 factorial is 1. So that's 1 times n factorial divided by n factorial is 1. So you only got one way. Okay? Just like sort of the way I'm trying to describe. Whereas in class, I also tried to explain a couple of other things, like what if you had nn or n1? It's the same concept. You see, if I had n1, okay, that means if I had 3, let's just hypothetically say it was, n was 3, hypothetically. 3 and 1. What I'm saying is, if I have 3 options and I have to choose one, how many different ways can I select it? Well, I can either choose A, or I can choose B, or I can choose C. So how many options did I have? I had 3 options. I had 3 different ways of choosing one. So of course, when you say N1, if you had 1,000 options and you had to choose one, how many different ways can you choose? Well, you got 1,000. So that's why N1 is equivalent to N. But again, you can show that through, using the formula n factorial over 1 factorial over n minus 1 factorial. And here we go. N factorial is the same thing as saying n multiplied to n minus 1 times n minus 2 times n minus 3. But, and then over the denominator, 1 factorial is just 1. And n minus 1 factorial means n minus 1 times n minus 2 times n minus 3. And conveniently, you can see these cancel out. That's why you got n, which is exactly what I was saying. Okay? So you can think about it logically. You don't have to calculate it through this sort of combinations formula. Now, and then lastly, there was a third scenario. What if you had n? Okay? Now, logically, if I asked you if there's 3 options and you had to choose 3, how many different ways can you choose 3? Well, if you have 3, A, B, C, and I had to choose 3, well, there's only one way. I can only choose A, B, and C. There's nothing else. Like, that's the only one way I can choose. There's my 3 that I can choose, so there's only one way. Okay, so NN is also 1. Just like you say when you say N0, if you have 3 options and you don't want to pick any, how many different ways can you do that? You can only do it once. Don't pick one. And that's an option. So that's why it's 1. So, having tangented off on that concept there, I just wanted to, because I think a lot of students struggle here. Like they see that and they're like, oh, I don't know how to solve this. But really, like if you think about it, it just means this is 1. There's only one way. Times 0.48 to the power of 0 is just 1. Times, in this case, is 0.52 to the power of n. Less than 0.05. So really, in your calculator, this is all you're solving for. And this is where I'm going to make a bit of a difference to how I taught it in class. I told you to type in solve, but the problem is that less than symbol, your calculator may be able to solve it, sometimes it can't. But I want to show you a sort of a method. Like what you're really just looking for is, this is a function and you want it to be less than 0.05. So why don't you just sketch it and just visualize it? Just visualize that. So here we go. I'm just going to bring up the TI Inspire. Okay, so let's have a look. Come on. It's going to take a while. I'm going to check my messages for now. Anything? Oh, it's up. Okay, add a calculator. Calculator. And let's zoom this in. Okay, so all I'm saying is I just want to calculate this. Let's just look at it. It's 0.52 to the power of x. I know it's n, but let's just call it x. All right, there's my function. There you go. And what do I want? I want it to be less than 0.05. So where is 0.05? And okay, so it's a bit small here, but let's adjust the window. Okay, let's do the height, let's say -222. Okay, so we can visualize it. Okay, so it's right over there. There's an intersection somewhere there that tells you exactly where 0.52n is equal to 0.05. Okay, actually, I'm just going to zoom in even more. Let's do zoom box. So I'm going to just box it right there. There you go. So what I want you to see is the blue is 0.52. I'm just asking when will it be less than. So obviously at this point and greater than that certain point, so x values, if I can just find my x value at this point and then onwards, that will tell me when I will have the blue line, which is the function, less than. How many n trials do I need to do? Okay, because remember x represents n trials. I'm just trying to see how many games I have to play minimum before I have it less than 0.05, and that answers my question. Okay, because remember red is the 0.05. So really you can just do menu 6 intersection and you can just check out point of intersection. So what does that tell me? It tells me at 4.58 games, okay, 4.58 games, it just tells me that that's when I would have exactly equal to 0.05, but I said I want it less than. So just to reiterate, just in case you still don't understand what I'm trying to say, I'm just saying this is what we want, less than. So the only way to get that is you just choose, if this is 4.58, I just need it to be greater than. So I just need it to be greater than 4.58. But to answer the question, see, the question asked you what's the least number of games. Now you can't play, and I know n had to be greater than 4.58, but you know, like, how do you play 4.5 games? You can't. So as soon as it's more than 4 games, you know you need to play at least 5 games. Okay, so n greater than 5 games will ensure that I'm going to get 95% or more. Okay, so if I played 5 games or more and the probability of winning was 0.48, that's the least number of games that will ensure that I'll win 95% of the time. Okay, that's all it is. So it all started off with this concept. I rearranged it so it's easier to solve, and I solved it by hand up until this expression, and then I used the calculator to get 4.58, and I now know from the graph that it is n greater than 5. So more than 5 games will ensure that I'll get 95%, or win 95% of the time. Does that make sense? Because in class, then what I did was I asked you guys to then solve the second part. Okay, because it's exactly the same thing. It says, what is the least number of games that must be played to ensure that the probability of winning at least twice? At least twice. So that's the only difference. At least twice is more than 0.95. Same concept as what I've been showing. Okay, I'm just going to clear out all of these ink, and I think I showed it maybe by hand, just so you can see what I was doing. So you can look at this again in the PowerPoint slide. This part here, this is what I did. I did that in a calculator initially in class by hand, and I showed it by hand, and you know, you get whoops, you do it by hand using log, because all I did was I did log of inverse, but you didn't have to do that. You can have jumped from here to the calculator and bam. Okay, but what I did was, because this is an exponential function, in order to make n the subject, I had to remove 0.52, so I just did log base e on both sides, brought the n down, so that's how I got n times log e of 0.52, and because it's times, I divide both sides by log e 0.52. The question is, if you're questioning why the sign changes, is because log e 0.52 is a negative number. How did I know that? because I know my log graphs in the sense that the x-intercept is 1, so 0.52, anything less than 1, where, you know, if you log anything less than 1, it's always going to be negative, like there's a negative value. Okay, that's just from your log properties. Okay, that's if you happen to be looking at my PowerPoint slide and you got confused in that step there, why the sign changes. And if you do this on your calculator, that should be your 4.58. And obviously we know that n then had to be greater than 5. Okay. All right, so hopefully you understood what I was trying to say, and then now your turn, you have to do what is the least number of games that must be played to ensure the probability of winning at least twice is more than 0.95, and it goes on to the side. So I said your turn, and if you've done it correctly, it's the same thing. All they did was, in order to find less than 2, because it says at least twice, okay, at least twice. Notice they skipped a step here. Okay, so what you would have wrote is you would have said probability of x greater than at least twice is greater than or equal to 2. And you want that to be more than 0.95. All they did was they skipped a step and they said, oh, well, this is the same thing as saying find out 1 minus the probability of what you don't want, which is probability of x less than 2. And then all they did was minus 1 on both sides. So then you get, and you know, negative probability of x less than 2 is now greater than negative 0.05. Divide both sides by negative, and that's where they got probability of x less than 2 is less than, because the sign changes to 0.05, and that's the step that they skipped. Okay, and then you know, same thing again. You know that to find less than 2, well, you got probability of x equals 0 or probability of x equals 1, meaning winning, you don't win at all, or you win at least once, or just once. Sorry, not at least once. You win once, or you win none. Okay, and then you use your probability distribution. Same thing again. It's n0 because you want to win none, and then win once. Same concept. Okay, and if you understood what I was saying again, if you had n times n trials and you're picking 1, how many different ways can you pick it? N. That's where the n came from. 0.48 to the power of 1 is just 0.48, and then 0.52 to the power of n minus 1, and this one is obviously 1, and that's 1. That's why you got 0.52n. Okay, and then on your calculator here, you see at this point here, you now know this needs to be less than 0.05. From here, this is what I'd say is just sketch that on your calculator. Okay, sketch it on your calculator and you'll get your answer. Now, the one I showed in this PowerPoint was, I said solve for it. See what the issue is when you write equals, well, how do you know? Is it n greater than, 8, or is it n less than 8? How do you know? How do you know it's greater than, less than? So that's why I'm saying if you sketch it the way I showed you just now, at least you'll know what the answer is. So I'm going to show you again how I would have done it. I would have gone to the calculator, and it was 0.52 to the power of x, and what was it? It was plus 0.48 multiplied to x. Remember, I changed it to x, and then times 0.52 to the power of, what was it again? X minus 1, was it? Yes, x minus 1. Okay, and here we go. So that's my graph. And there you go. So this is my new graph, and I'm still wanting it to be less than 0.05. So there we go. That's obviously, this is the point, and for it to be less than, obviously I need to know this point. See, this is the point of intersection. I can tell that is the number of games I need to play. And for it to be less than, which is right here, you need to choose a number that is greater than this particular point. So all you have to do is figure out that point. Okay, so to figure out that point, I'd go menu, analyze, intersection, and there we go. Oh, it tells me it's 7.8. Okay, so I need this point here to be. So if I just go back to, where was this it? I don't know. I'm going to do it again. So I know that this point here is 7.8. So in order to get it less than 0.05, I had to choose n greater than 7.8. But because we're talking about games, how can you have 7.8 games? So obviously you have to at least play 8 games. So 8 or more games will ensure that you will get what you're looking for. Okay, so greater than or equal to 8. And there you go. That's answering my question.